Welcome, everyone. Welcome back to part 2 of the Integrated Parasite Management workshop with Betsy Hodge and Tatiana Stanton from Cornell Cooperative Extension and the Cornell Sheep and Goat Program. I'll pass it over to you two if you want to introduce yourselves, and Betsy, give the Zoom introduction. That would be wonderful.
Sure. I'm Betsy Hodge, and I am the livestock educator in St. Lawrence County, New York. Of course, I have a cat helping me here tonight. I'm just going to go through a little bit of the Zoom etiquette before we start, and I'm excited about this second half because this is really good information about what can you do about all these parasites that seem like they're so well evolved. So tonight's presentation is being recorded, so just keep that in mind when there's background noise. Ideally, you'll keep yourself muted until we're asking for questions, or feel free anytime to write your questions in chat or raise your hand so we know you want to do that, and I can show you how to do that. So the view for speaker view, which is you probably have anyways because I'm sharing something, but that's where there's a big picture and then little people along the side. Now you go to view and click on speaker view. View is usually up in the upper right corner. There it is. And the little mute button's down on the lower left. And if you click it and there's a red line through it, that means you're muted. And there's that little conversation box is the chat. If you click on that, a little box will open up and you can write in to everyone or to individual people your questions, and we can see them as long as we're included in who you're sending it to. And we can answer some things right in the chat, or if we get a lot of questions in chat about the same thing, we can stop the speaker and talk about it. And if you want to send other reactions or raise your hand, it's under reactions, which is also down on the bottom usually, unless you're sharing your screen. So Todd, I'm going to stop sharing so you can start.
Okay, is there anything I need to do to be sharing?
Oh, you got to find your PowerPoint and click share, and
okay.
There you go, and then screen and introduce yourself.
Yes, I will. Okay, and I'm gonna make this
slideshow.
No, I somehow don't have it full screen, so I'm trying to figure that out.
I will go to full screen when you hit slideshow, I think.
Okay.
And if you go to the left where it says from beginning or from current slide, if you click on that, it should go to full screen.
Okay, it did. Yeah, thank you all for your assistance on that. Okay, so I'm Tatiana Stanton. I'm the sheep and goat extensionist for the state of New York, working out of Cornell University. Like Betsy, I also raise my own small ruminants. I have a herd of pasture-based meat goats, primarily boars and boar alpine crosses. And I originally came out of, I've worked with dairy goats, meat goats, brush goats, not as much with fiber goats, but I have a lot of practical experience and unfortunately have dealt with a lot of parasite issues myself, and also have done research, applied research with different types of parasite control. So I'll talk about a little bit of what we've done that way as well. So today we're starting out on part 2, which is know your weapons, sort of know what you can do to manage your parasites. We talked last week, we ended up at the end of our discussion, we had talked about chemical dewormers. And right now I'm going to sort of emphasize pasture management, including evasive grazing, and a few other things, and then nutrition, genetic selection, and the immune system, and then selective deworming. And then we'll go into part 3 after that. Okay. And I'm having trouble getting it to move to the next slide.
If you click down, and there you go.
Yep. Okay. All right.
So there's a lot of things you can do that are not with drugs.
And Betsy, I'm back.
You're back. There you go. We just got back to sharing my PowerPoint. Are you ready to share yours? And I'll stop sharing here.
Why don't we, is this the one from Box?
This is the one that from last week. So if you've
I think
changed
let's
things.
just go ahead and use it. There were only 2 changes I made and I can remember them, I think.
Okay, so you'll just give me a
And that,
nod when
and
it's
that
time.
way, if I freeze up again, you can just keep going.
Good
Okay,
point.
all right. Okay, so when we look at grazing management to reduce our barber pole worm problems, and a lot of this would be true of your other strongyle worms as well, we're hoping to use clean and safe pastures because the pasture contamination with worm eggs is strongly influenced by the height of your pasture, your grazing duration, how long are you leaving the animals on the pasture through this cycle, and then how long before you come back on the pasture. How long does that grazing paddock get rested before the animals are back on it? And this can be difficult to implement these recommendations for your entire grazing season. You can also use multi-species grazing or alternative forages. And for a lot of the stuff I'm going to be talking about when it comes to evasive grazing is going to be really hard to do with the whole herd. And so your priority would be the most vulnerable animals, such as your recently weaned kids and lambs, or your lactating does and ewes, as compared to your dry stock. As far as, so you may not follow all this advice. Next. Okay. And so basically you've got this cycle where your ewe runs out to the field, she squats and she pees and poops. And in that poop, you've got your eggs, and then they go through several stages, and then they crawl up the grass and she eats them again. Okay. And they can't crawl very far from where they've hatched. It is as much as several feet. Okay. And then next slide. Okay. So the eggs are in the feces and they fall from the animal to the ground. And for barber pole worm, it requires warmth, but that can be as cool as 50 degrees Fahrenheit to get a lot of hatching. And you get lots of response by 60 degrees Fahrenheit. And unfortunately, in the Northeast US, our temperatures tend to warm up pretty fast in the spring. You know, as you can see from what this last week has been like in most parts of the Northeast. And it requires humidity. And it hatches into that stage 1 larva at that point. And for barber pole worm, if you want to be more exact, it says it takes about 3 to 5 days to hatch in the upper 70s, and as much as 15 to 30 days to hatch when the temperatures are about 50 degrees. And the L1 eats bacteria in the feces and it grows. It just pretty much is very happy to just stay in that feces. And then it molts just like a snake would, you know, it sheds that skin and it becomes an L2. And the L2 does the same thing. It generally just stays in the feces and eats bacteria there and then molds again. And if your goat was to eat or sheep was to eat either one of these, L1 or L2, they wouldn't complete a life cycle in it. These aren't capable of becoming, you know, getting into your animal and becoming an adult. Keep in mind that direct sunlight can heat that fecal pellet to 155 degrees Fahrenheit. And at that point, that pellet of feces is sterilized and those eggs aren't going to survive, let alone those L1 or L2. And because of that, we'll sometimes recommend that as you move animals out of a pasture, you know, if you've had them there for a few days, as you move them out, if you can mow that pasture really short, that can aid. Unfortunately, except for our first pass through in the spring, when you mow, even mowing it short, even if they grazed it pretty well and then you mowed it, there's not going to be much mulch there. But otherwise, if you're moving them every day, which is, you know, or every few days, which is often recommended, and you go to mow it, you're more just putting a lot of mulch on there for them. That's going to protect those worms even more. So this mowing is really only effective when you've already, when it's early in the spring, so it's been grazed pretty short, and then you mow and the sunlight is really able to get in there and hit those fecal pellets. And because of that, your shade trees and your tall, dense grass, keep in mind that there's usually a lot of survival of your L1 and L2 larvae in those situations within the feces. There's a lot of survival. So while it's nice to have shade trees out there, there's a bad side to them when it comes to survival of your L1 and L2. The L2 then molts into an L3. However, this time the L3 is evolved to get out of that feces, get out of that fecal pellet. And because of this, nature has made it so that it doesn't shed that previous skin. It keeps that skin and it gets a second skin on it, which makes it much less susceptible to drying out. But because it's got this skin over its mouth, it cannot eat. And it has to live off of its stored reserves. Worms aren't cold-blooded, so their metabolism speeds up when it's hot. So therefore, the barber pole worm L3 larva can only live about 30 to 60 days in hot weather. In cool weather, it can live about 120 to 240 days. And we used to say that the barber pole worm larva can't survive freezing. That this is not does not necessarily mean that it can't take super cold temperatures, and we'll talk about that more later. Next, so it takes about 5 to 14 days for the egg and the feces to go from being an egg to being an L3 larva. And in some cases, I know this previous summer when it was really warm and humid, we were finding it taking less than that. You know, it was taking more like 3 to 4 days sometimes. But the pasture becomes infectious at this time. So when your animal's been, this time of year or a month from now, it's only going to be taking about 4 to 5 days to go from being eggs to being infectious. And most of these L3 larvae can't get more than about 2 inches high on a blade of grass. They come up with the morning dew or with the rain. They're able to, their movement is dependent on water flow. So they come up with that. And then as the sun dries that dew, they go back down to the soil level. Okay. But they're heavily concentrated in their first 2 inches. The L3 has to escape from the fecal pellet in order to infect your goat or sheep. And it can only live about a week or 2 inside the fecal pellet if it's hot and dry. The pellet has to be broken up by rain, and that's about 2 inches of rain in a month's time. And unfortunately, in the Northeast, we usually get those 2 inches of rain per month. And then if you also think about what your animal's feces are like right now, most of your animals aren't having hard fecal pellets right now if they're out on pasture. They're having really soft, manure, which is really easy for this L3 larva to get out of. And then it to protect itself, it gets under fallen leaves or in the debris. And then, like I said, it scoots up and down your forage with water. Okay, next. So it's definitely survival of the fittest, and only about 2 to 10% of the eggs end up becoming L3 larvae. But unfortunately, with barber pole worm, that's still usually a lot of eggs. In the tropics, the population of L3 after fresh manure has been deposited in a pasture peaks at about 14 days afterwards. And unfortunately, in temperate climates, it takes it about 35 days to peak. So this doesn't mean that you're leaving your goats out there. It means, or your sheep out there. It means that if your animals are in an area for about 4 days, that if you move them out of that area from the time the fresh manure started, it's going to be about 14 days after that in the tropics that the population of L3 on the pasture is going to peak. And unfortunately, in our temperate climates, it's going to be more like about 35 days after, because it takes time for it to hatch. And for some of them will start hatching, like I said, as early as 4 or 5 days after. But by 35 days, pretty much they're all hatch a lot of, okay. Then it has to be eaten by a goat or sheep to continue development. Cattle and horses can vacuum up the L3 larva from barber pole worms in sheep and goats, but they have a specific barber pole worms of their own. However, there are species of barber pole worms that infect sheep and goats and will infect young calves as well. So you need to keep that in mind. Okay, and so if the larva, L3 larva, is vacuumed up by your adult cattle and horses, it usually will stop its life cycle. It won't be able to continue. And like I said earlier, they used to think L3 couldn't survive freezing and couldn't survive outside in the Northeast winters, but they've done studies at University of Maine where they took barber pole worms from Maine and from Virginia, and they found that they could tolerate about 10 degrees Fahrenheit for up to 3 to 6 days before they got significant dying off, versus they took barber pole worms from Georgia, and those that came directly from Georgia, that they had been, were from goats and sheep in Georgia. And they found that those started dying off significantly at about 20 to 25 degrees Fahrenheit. So unfortunately, as barber pole worm has moved north, it's become, it's genetically been selected to survive colder and colder temperatures. So it's probably just going to get more and more tolerant of cold weather. And once the L3 is inside the goat, it leaves that sheath, and we call that sheath the second cover, that covering that's going over its mouth. It leaves that sheath and it molts into the L4. And then it can make a choice. It can either decide to stay in L4 and overwinter in the goat in a state of hibernation or a state of suspended animation, or it can become an L4 and then decide to become an L5. Okay. And that has to do with how many worms are already, mature worms are already in that particular sheep or goat. If there's already a lot of worms there, then there's feedback mechanisms that L4 larva get that tells it, oh, they're ready. There's too many mature worms. I'm going to just stay in immature. I'm just going to go into hibernation. And also has to do with the season of the year. It's able to see, it has triggers that let it know what kind of day length is going on, and it can decide, oh, winter's coming, it's time to hibernate, and not become a mature adult. So we have a term called evasive, or sometimes it's called avoidance grazing. And this is a method of grazing that is dependent a lot on your parasites. And you make your decisions, a lot of your decisions based on parasites. And it means that you're going to move your animals fast enough out of a grazing paddock to prevent them getting infection from feces that's been deposited during the current grazing period. And the fancy term for that is autoinfection. And so it's going to, for barber pole worm, be at the shortest about 4 to 5 days, up to about 14 days during the grazing season for it to go from being an egg to an L3. So we usually advise farmers to play it safe by moving your animals out of a grazing paddock within 4 days, in about 4 days if it's a wet, warm time of year, to about 7 days in the cooler, drier part of the year. And we also say move them earlier if the pasture is getting too short, because remember, those worms are concentrated in the first 2 inches of forage. Okay. And these recommendations for how long to leave your animals in a pasture and how tall to let your pasture get, we want it to be way over those 3 inches, and as you move out of the pasture, we don't want it to be any shorter than 3 inches. These recommendations are also very good for the health of your pasture and the nutrition of your pasture. But unfortunately, the next recommendation is not good for the health of your pasture or the nutrition of your pasture. Because we're saying that you need to allow a long enough rest period before you return to that particular grazing paddock, that you're getting substantial kill off of the L3 larva, of that infectious larva, before the animals come back to graze. And unfortunately, that's about 60 days at the shortest. and about 105 days at the longest. So Cheryl is asking if they can also crawl up broadleaf plants. They can, but it's more difficult for them. And so it's harder for them to get up as high on a broadleaf plant. At the same time, when it comes to clover and alfalfa and probably your bird's foot trefoil, they can still get up, but part of it has to do with there's so much branching going on versus when you think of a blade of grass, the blade of grass starts pretty close to the ground and then goes up. And so an animal can go pretty high on it versus they're having to make a lot of choices of where to go if they're trying to come up a legume or a lot of your broadleaves. You know, they come to a branching point, and so you're losing more and more of them as it branches. And some of those plants also have compounds that may help to make it harder for the animal to get up there. You're not getting this smooth flow of water, morning dew going straight up. Next. Okay, so that I mentioned that this last recommendation is not good for your animals getting nutrition from the pasture. And so the big problem is that these pasture rest periods that we're recommending for evasive or avoidance grazing in order to control barber pullworm are much longer than what you would normally recommend for either the health of your pasture or for the nutritional value of your pasture. And this is a picture at my farm many years ago when I didn't have as many, you know, my animals were just like first generation boar crosses and stuff. And my does had come into this field the day before, and they had come in there and they were, you know, the grass was tall, you know, it'd been a long rest period, and they came in here and they just, you know, trampled it down. It was high, you know, lignified enough that the stems had gone down the day before and hadn't bounced back up, you know, this day. And they went through this, and then the day before they'd gone through this and broken out into my hay field next door that had been mowed for hay about 4 weeks earlier and had really nice, you know, young regrowth on it. And they'd gone out there and grazed that. And they went to do the same thing this day, and luckily the fence was harder, so they weren't able to, but they knew that the stems were getting lignified. There was still a lot of good grass out here and good nutrition out here, don't get me wrong, but they knew the stems were lignified and they wanted out of there. Next slide. Okay, so how good does parasite avoidance or parasite avoidance work? And sometimes it works pretty significantly. This is a study they did at West Virginia University with their organic sheep flock, where they did what they call it avoidance grazing. And the animals grazed a paddock for 3 days, and then they didn't return to that same paddock for at least 57 days. And then they had challenge grazing where the animals were left in a paddock for 7 days, and then they returned they only had a 21-day rest period before they returned to that pasture. And they found that they had twice as many strongyle worms in those pastures that were challenge grazed, the ones where they didn't have as long a rest period, and where they kept them in there a little longer grazing. And because of that, they had to treat much more of the lambs that were on those pastures, on those paddocks. They had to chemically treat them. So they were only able to market about 46% of the lambs that were that they managed under challenge grazing as organic versus the lambs that they managed under avoidance grazing. They were able to market 83% of them as organic lambs. And at this point in the study, they waited later before they, you know, sold them for meat. But when they finished this study, the weight gain was better on the ones that had avoidance grazing. So even though you had this nutritional, even though the nutrition was not quite as good because the animals were coming into the pastures for their second, you know, for their later grazings after the pasture had grown out more, they still got more nutrition because they had less, you know, less of a parasite load. Next. So are there safe pastures that animals can be switched to as the grazing season progresses? And that's one thing to think about, because by the time we get into July, often our pastures are pretty infected, regardless of whether you're using evasive or challenge grazing. Do you have brush pastures or hayfield regrowth that your animals can go on? Or do you have pastures that you've had cattle or horses grazing on, and can you switch from that set of pastures to these set? Do you have crop residuals, and do you plant some annual pastures? I know some of our sheep farmers in New York are very good about renovating their like 1/10 of their pastures every year. And so they'll take those pastures that they're renovating and they'll disc them and plant them in annual pastures for a season. And that way like your King's Agri-Seed makes your crazy, I forget, crazy who mix, and stuff. That's got some cowpeas in it and sunflowers and fast growing sorghums and stuff in it. They'll put them on something like that to help break the cycle. And often you would use something like that for your most vulnerable animals. So like for those lambs or kids right after weaning, who are going to be very susceptible to parasites, or your lactating animals. Also think about whether you can disrupt the worm cycle by mowing the pasture extremely short at the beginning of the rest period. And again, I said that only works when you don't have a lot of mulch that's going to be ending up being on there by you mowing it short. Can you graze another species on there during the rest period? At our farm, we have a couple of horses, and so the horses graze those pastures in between. And can you harvest a hay crop or baleage? We do have hay fields at our place, and so our goats, after weaning and stuff, most of our herd goes out onto hay fields, and we leave our conventional pastures to rest until we come on them again in the fall. But a lot of people don't have a hay field, don't have that ability to have hay harvested. I know I'm getting a lot of questions. I'll go into those in a minute. And next, do you have some pasture alternatives you can go on to? So if I was in California or Texas, I would usually be saying, hey, can you get them out on the browse or the brush? But in the Northeast US, particularly in New York, but more and more in other states, we have a lot of problem with the deer worm, as we discussed last week. And even though 80% of your other worms live in the first 2 inches of vegetation, so you don't have a lot of problem with barber pole worm when you go out on browse, unfortunately, you run a higher risk of deer worm. And so if you are going to use browse, try and use it at a time of year that you think your deer worm risk is going to be fairly low. Use it when you don't think there's going to be a lot of snails out there. And unfortunately, your brush snails that can get about 2 feet up high on brush, they can get deer worm. And so, you have to consider that. But during the drier times of the year, you can go ahead and, you're fairly safe to be grazing your brush. And also, I'll talk about it later. It appears to be that sometimes grazing high tannin forages can help reduce the effects of parasites. And we'll talk about that more later. Next. I'm going to talk about the barnyard effect, and then I'll address some of the questions we have. So barnyards are really any small pasture or barnyard you have that has good forage in it. So it has a high concentration of manure in it, which means it's usually got a high concentration of internal parasites in it. And unfortunately, it also has good grazing there. So your goats and sheep are going to tend to want to graze there. And this can contribute greatly to the herd contamination, to your herd's contamination with internal parasites. We used to bring our animals in at night, and we'd have a little little paddock outside besides the barn, and they would go out there and graze, and that was a real problem for us parasite wise. And I've worked with one organic farm here in New York where it's a major problem. They really want to bring the animals in at night, so they bring them just to keep them safe from predators. So they bring them into a 2-acre area every night. So even though they're rotating their pastures at night, that stops, and the animals don't stop grazing at night or early in the morning. And so look at those areas and decide if you really need them or not. And is there a way to fence your animals out of it? And in our case, we ended up making another barnyard that's in front of our barn where our septic systems are and has no forage in it. And we use those for our animals instead if we feel we need to bring them in at night during the grazing season. Okay, and you can also have a barnyard effect in pastures that border the barn and aren't being rotated, or that you're using early in the spring for lambing and kidding in, things like that. Next slide. Okay. Rotational grazing in the spring does appear to reduce your barnyard effect and delay the onset of your summer parasite problems. And we did a study in quite a few years ago, just an informal study in New York and Vermont, where we had one farm that wouldn't rotate at all, and then 2 other farms that were rotating in the spring. And then the plan had been that we were going to take those animals that were rotating in the spring and summer, and they would early summer, and they would go onto hay fields or onto brush pastures. And then these pastures that were rotating or that weren't rotating, we would compare what happened. But we had to, next slide. We had problems with the study, and this is the New York State, but the same thing happened in Vermont, where the farm that was doing no rotation, by late July, they were having deaths in their weaned lamb, in their lambs and kids. Actually, this was all with goats, so they were having death in the goat kids, even though in previous years they hadn't. But the population of goats on the land had just gotten high enough that even though they were grazing quite a few acres, I would say probably 50 does on 25, 30 acres, they were having a horrible worm problem. You can see that their strongyl worm counts were almost 24,000 worm eggs per gram, versus the ones that were rotating. And these were not doing long rest periods in their rotations. They were more practicing intensive grazing, where they were, staying off of a pasture for 35 days max. They too had a lot of worms. They had like 3,500 or 2,000 worm eggs, and they were pretty eager to go onto their hay fields or their brush pastures at this point, but they were having no deaths in animals yet. It definitely was very helpful to do rotating versus continuous grazing. Okay, next slide. Okay, so some options to help reduce this barnyard effect. See if you can do any of these. In some cases, you can lay down gravel, concrete, or herbicides in your barnyard. I had one of my veterinarians, Mary Smith, told me to do that, and I asked her, who's paying for it? And went, nope, that's not an option here. You can close off access to the barnyard, and that's what we decided to do at our farm. We just made well, actually, I guess we did the third one, and I'll talk about that. Or we came up with new barnyards. And then, can you provide hay in the barn at night when you're bringing the animals back in, if you do bring them in at night, to cut down on the amount of night grazing you get in those barnyards. And then what we did at our farm is we made the barnyards so small that no grazing could occur in them. The animals could graze for like one day, and then they'd wiped out all that it was there. And so that's what we initially did. And then I said, as later on, we made another barnyard. And then more and more what we do nowadays is we just leave the animals out 24/7. They don't come back in. Okay, next slide. Okay. All right, so I'm going to answer some of the questions now that are in chat. Okay. Yep, we all have the thunderstorms going on. And I probably should turn off my video, actually. That might help here. And I'm forgetting how far they can really crawl, horizontally on the land, but it's not very far, Saber. Like I said, I think it's about 2 feet, sometimes 5 feet. If there's water movement, they can go quite far on the water movement. So if you've got a big manure pile outside of your barn right there in the pasture and you've got rain, then that manure as well as those larvae can move quite far. And so I mean, there's definitely going to be a lot less worms in that adjacent area that your goat isn't directly pooping in than there is right in the barnyard. So I'm not sure I would worry that much about it. So yes, they can crawl up broadleaf plants, but generally not as well and as far. You can bring chickens in, but if the sheep haven't grazed the pasture really short, then the chickens scratching the feces, the fecal pellets, isn't going to be that much help. But often if you do bring your chickens in, they will scratch fecal pellets. They just won't get enough of your fecal pellets. If you've got a really small flock, then it can be helpful, but otherwise it's probably not a real major help. And we certainly have a lot of farms that do pastured poultry that also have barber pole worm issues and stuff at time, but it can help a little. And yes, I mean, they probably do, the L3 is so small that I don't know if they specifically try to eat it, but yeah, I mean, they are helpful that way. And mostly they're helpful by breaking up those fecal pellets. Grazing, so the recommendations for grazing height out and regrowth time, I'm confused by that. So normally we would be saying you want to move animals out of a pasture before they start doing much eating of the regrowth. So there'll be like a 4-day rule is what Woody Lane, one of the more famous pasture management people, will say, that you want to move them out of there in about 4 days, because after that they start grazing the regrowth. You always have to look at it economically. A goat dairy may be moving them out every day because if they're commercially selling that milk, because for nutrition and everything, that fresh forage every day can be helpful. If you've got a meat goat operation or something, or meat sheep, then the time and labor it takes to move them out daily, it's going to be even hard to justify that 7 days. But as I said, it's more at 4 to 5 days. So and then when we talk about pasture height, it's more a matter of the maturity of your pasture. You're trying to keep your pasture from getting too mature, from flowering, and the stems getting lignified. So it's hard to say. It depends on the plant species and everything. But usually, I mean, early in the season, I'm not too worried if my pasture gets down to 4 inches. But just within a few weeks, like right now, my pastures are getting so tall that keeping up with the next pasture, I'm probably moving my animals at 5 or 6 inches, and I'm bringing them into pastures right now that are already hitting 8 to 10 inches. So Betsy might have some advice there. And then the big thing is, that regrowth time. Normally regrowth on an intensive system, we would be talking about coming back in 28 or 35 days during the peak of the grazing season. And then later, as you get into the fall and things are growing slower. But as I said, for dealing with barber pole worm, you need a lot longer rest period. One thing to keep in mind with invasive buckthorn is that some farms do not have much trouble with it as a poison, but other farms do have problems with it as a poison if their animals aren't used to it and their animals eat a lot of it all at one time. We've lost sheep at the Cornell sheep farm, at the teaching farm right on campus to buckthorn, versus I have goats and sheep or goats out at my farm. And I know a lot of people with sheep who don't have much trouble. So just keep in mind that buckthorn can be toxic. And then someone was saying that the Vermont Agency of Ag is starting to fund wood chip pads for your barnyards through the BMP program. So I'm not sure what BMP stands for. It might be some sort of equip program or something. And so Kelsey, people are asking if they can, and you've given them a link. All right, great. All right, so I'm gonna get back to the other stuff now, if that's okay. And okay, so one thing we talked about how L4 larva, barber pole L4 larva can make a decision on whether to overwinter or not when it gets into an animal, whether to go into hibernation or not, or whether to become an adult. And many of your other strongyle worms also have to make this decision. And it's sometimes called hypobiosis. And so often what happens is they do make that decision to overwinter as a dormant L4. Barber pole worm typically does this. And then what happens is there's an estrogen surge in the host animal, in your sheep and goats at birthing. Just as part of birthing, estrogen is released. And unfortunately, the adult female worms have estrogen receptors. So they are aware of when you get that estrogen surge in your sheep and goats at kidding and lambing. And that triggers these L4 larvae to become adults and to mate and start producing eggs. Also, additionally, the immune system is compromised by parturition and late gestation. And it can also be, and that early peak lactation, all of those compromise the immune system, and illness can also do that. And so those also trigger L4 larvae to break out of dormancy. And as I said, other strongyle worms, the same phenomena occurs, but they have the option of also overwintering pretty easily outside. Next slide. And this was a study that Dr. Jim Weber did at University of Maine, where he took the flock of Icelandic sheep that they used to have at the university. And I believe they had been dewormed as they came off the pasture. And I'm not sure if that's right when this is occurring, or whether they were dewormed and then had come back up to 1,000 worms. But at any rate, over the winter, the worm load was way down. They had essentially no worms inside the barn. And then as the animals started to lamb in the spring, in March, those L4 larvae hatched out, or excuse me, became adults. And they started laying eggs. And so you started getting a lot of egg laying going on, and their fecal egg counts went way up. Okay. And then so they took half the herd, and half the herd went out to pasture May 15th. And that half that went out May 15th, they got out on pasture, and for a little while their worm counts were down as they got on those nice clean pastures. And then they rapidly went back up again. Those eggs they started laying eggs again, getting more contaminated. The pastures got more contaminated, and the worm loads went way up, the amount of eggs per gram in the feces. Versus the other half of the flock they kept in the barn while they were going through this peak, this surge of adult worms you get after kidding, or after lambing, and the surge of egg laying that you get, that these worms go through when they get all that estrogen. And they left those in the barn, and they just naturally dropped down, because in the barn they couldn't get recontaminated very easily. So the counts dropped drastically. And then the animals went out to pasture about June 15th. And they were taking that manure was being removed from the barn. No, I think they were on a bedded pack, but he said that they weren't able to contaminate their mangers very easily. And then the worms stayed down for much of the grazing, much of the heavy grazing season. And then they did, by August, they were going back up again. Okay. So then he was saying, if farmers could afford to keep their animals in the barn till June 15th in May, he would recommend that. But most farmers were saying there's just no way I can keep them in the barn that long. But it does sort of indicate how important this spring rise in worm and egg laying is. This rise in egg laying before, right at lambing and kidding is on infecting your animals and infecting your pastures. Okay, next. So now we're going to talk about your immune response. And keep in mind always that good nutrition stimulates the immune system. Good nutrition is one of the big things you can help to boost the immune system of your animals. And then there's also many trace minerals such as zinc, selenium, and copper that are very, very involved in the immune system. And of course, too much copper is toxic to sheep. So you have to be very limited in how much copper you're giving your sheep. And then vitamin E also plays a very important role in the development of the immune system. And keep in mind, like I said earlier, that when goats and sheep are lactating or in late pregnancy, that immune system is suppressed. And they found that if you're able to boost the nutritional diet of ewes in late pregnancy so that they're getting 130% of their daily protein requirements, that this does reduce that spring rise. It reduces the flush of egg laying. And they think it's primarily because the animals have really good immune systems going into lambing. And so therefore the L4 larvae don't get those triggers to go ahead and do a frenzy of egg laying. So keep that in mind, that late pregnancy isn't necessarily a time, to go low on your protein, that you actually can. There are some advantages to going at 130% of the daily requirements for a late pregnancy animal. And then at University of Rhode Island, they did a study where they looked at, in 2007, the Natural Resource Council had greatly upped the amount of vitamin E they said that sheep needed. And this would be the same for goats. And so they upped the requirements. So what University of Rhode Island did is they compared the old requirements to the new requirements. And Cornell had calculated out, Doug Hogan, Mike Toney had calculated out that you would meet the NRC requirements, the new requirements, if you put 10 international units of vitamin E per kilogram live weight in the creep feed of lambs versus the old requirement, which would have been about 5 international units per vitamin E per kilogram of live weight. And so they attempted to do that with their creep feed, and then they artificially infected the lambs, these weaned lambs, with barber pole worm larvae. And they found that the lambs that got the twice as much vitamin E had about half as many their fecal egg count for barber pole worm was about half as much. And so that's one reason why we do recommend sticking with that higher amount of vitamin E supplement in your trace minerals or your creep feed if you can for your lambs. Next study, and same thing with goat kids. Genetic resistance. The susceptibility of animals your sheep and goats getting infected with your strongyl worms is greatly affected by the environment and genetics. And the heritability for genetic resistance to strongyl worms in sheep and goats appears to be similar to the heritability of milk yield in dairy cattle. So it's like in dairy cattle, it means that it does require a lot of records because the heritability is only about 0.25 or 0.3 and so it does require a lot of records. So it would be more comparing the fecal egg counts of offsprings of different sires rather than comparing the fecal egg counts of individual litters to each other. You more want to have different sires that you can compare. And the National Sheep Improvement Program, NSIP, as part of their on-farm genetic testing, they do have traits in there for looking at fecal egg counts and trying to breed for dewormer resistance in your sheep or goats. Next slide. And so this is just the two traits they have. One is fecal egg counts at weaning, and one is fecal egg count post weaning. And if you look at their website, it explains it more. But the Katahdin Sheep Association has really embraced this and is making a lot of headway on parasite resistance in their animals. We have very few, if any, meat goat farms, I think, enrolled on NSIP right now. But if you were to enroll, this would be one of the advantages of doing it. But you have to find a way to get your fecal egg counts done for you. I know for University of Rhode Island for a while, and I think they may still be doing it, I'm not sure. But for flocks in the Northeast US, flocks and herds of sheep and goats in the Northeast US, they were, especially if you were enrolled in NSIP, they were doing fecal egg counts for free for farms that were specifically looking at these two traits. So they would do them right at weaning for you and then post weaning. Otherwise, learning how to do them yourself is good, but it's time consuming. Next. Oh, go back one. Can you go back one, Betsy? I'm sorry. Okay, so the mechanism of getting the immune system to function, or a biological resistance. The animal's immune system needs to recognize that there's a parasite infection occurring. And how quickly the animal recognizes this varies between breeds and also between individuals within a breed. And then the second thing is the immune system has to be able to mount an effective response. And again, the effectiveness varies between individuals and within individuals, and between breeds, and then within individuals in a breed. Next. So this is a study they did at West Virginia University, where they looked at St. Croix sheep and they looked at Suffolk sheep. And what they did with both sets of sheep is they took 3 groups of lambs, and one group of lambs, which are these red ones, had been exposed to barber pole worm by an artificial infection once, and then they were exposing them a second time. Okay, and excuse me, I'm wrong. This red line are animals that were being exposed for the first time. So they gave them the barber pole worms here at day 0. And then 2 weeks later, the worms had become adults and started to lay eggs. And the worm counts went way up until they got to about 3,000 worm eggs. And then the animals realized that, wait, I've been infected. And they mounted an attack on their immune system, mounted an attack, and the worms, the egg load went way down. And then blue, which you can't see, are lambs that weren't infected at all with the barber pole worm. And then the green are the second time these lambs were infected. So this is the first time they were infected. And then the second time they were infected, the St. Croix sheep instantly, realized that they'd been infected, and their immune system instantly attacked those worms, and they didn't get, they had no worm count increase. Versus when they looked at their Suffolk crossbred lambs, this is the first time they were infected, and you can see it took them until they got 7,000 worm eggs before they realized that, oh my gosh, I've been infected with worms. And they mounted up very quickly in them. So at sort of that same 2-week period, they realized, oh, I've been infected. So they realized it pretty quickly, but they had a really high load by then. And then it plateaued. It took them a while for their immune system really to kick in. And then even when the immune system kicked in, eventually the worms recovered and started laying a lot of eggs again. And for their naive ones, they stayed down because they were never infected. And the second time they were infected, yes, it took these lambs were able to realize they were infected earlier on, and they were able to mount a more successful immune response, but even then it went back up. And you can see when we look at the worm eggs attacking, which unfortunately, I guess this isn't going to work. Oh yeah, can you do it for me? Yeah, you have to do it. Right. You can see on the St. Croix, as those cells attack that barber pole worm in a petri dish, those immune cells, they're able to keep that worm from moving around much at all. Versus on the Suffolk, go ahead and click on the Suffolk now, Betsy. The worm is much more able to flip itself around and stuff. So you can see it's probably doing a lot more sucking of blood from the abomasum, even though it's being attacked, than the worms in the St. Croix. Next slide. Okay. So in traditional parasite control, it used to be that we would maximize that parasite control in the hope that we would maximize our production and theoretically help. And you would deworm the entire herd regularly in order to meet the needs of the most vulnerable or most susceptible animals. And we would often rotate those dewormers during the year or every year. And each time we would deworm, we'd move the animals to a clean pasture, so that they wouldn't be able to reinfect themselves very easily from the original worms in that grazing paddock. And all of these practices, unfortunately, promote dewormer resistance when it comes to the barber pole worm, which has such a heavy egg laying, is such a heavy egg layer and has such a short generation interval. And this has now become a huge problem in the United States. Next slide. And this was a study we did in 2007 with a set of New York and Pennsylvania goat herds. We took fecal egg counts right before we dewormed the animals, and then 7 to 10 days after deworming the animals. It was 7 days if they used ivermectin and 10 days if they used Safeguard. And what we found with Safeguard, which would be your fenbendazole here, there were about 6 herds where there was severe resistance to the Safeguard. In fact, in one of the herds, the worms actually increased their number of worm eggs after being dewormed with the Safeguard. There were 2 herds that it was still quite effective in, and then 3 were there it was moderately effective. Ivermectin fared a little better. There were 6 herds out of the 13 herds sampled where it was still highly effective. But again, there were 5 herds where it had severe resistance, where it did not kill very many of those adult worms when you compared the amount of egg laying that was going on 7 days after deworming versus right at deworming. And unfortunately, this herd here was my herd. So in my herd, ivermectin was candy. Okay. Next slide. So even in 2007, we had a pretty pronounced problem with dewormer resistance in New York and northern Pennsylvania. So the big problem with the traditional way of doing things is it destroys the refugia. And the refugia is just a fancy name for the proportion of your worm population on your farm in your sheep and goat herd that hasn't been exposed to a dewormer treatment. And so it would include the worms in untreated animals, in goats and sheep that you haven't dewormed, and also the worms in the larvae that overwintered in that pasture, that were in that pasture before you gave your animals any dewormer. And unfortunately, it's very hard to find a pool of genetics in a herd in New York and in probably most of the US that where somewhere back in that worm genetics, there hasn't been some deworming done or a lot of deworming done. So even if you're not deworming now, their great grandparents got exposed to a dewormer. But primarily we're talking about in this year who's been exposed to worms. And the good thing about refugia is it does provide you a pool of genes that are sensitive, hopefully, to the dewormer. And it dilutes the genes that are resistant. So if you've got your susceptible parents and you've got a couple of resistant parents, and you use your, they're going to crossbreed with each other. But meanwhile, you've used your dewormer. So you use your dewormer, and before you use the dewormer, all of these were crossbreeding with each other. So the genes, the resistant genes from these worms here were getting diluted by all the susceptible genes in these worms here as they were crossbreeding. But once you dewormed, the only generation that survived were these resistant worms, unless you spilled the dewormer on the ground, the animal spit it out or something. And so all you're getting are these resistant worms crossbreeding with each other. And if you're now moving the animals to a clean pasture at this time, all the breeding all the worm eggs that are going to show up have a very good chance of having some resistant genes. Versus if you'd moved them when things were looking like this, there was a lot less chance that the worm eggs would carry a lot of the resistant genes. Okay, next slide. Okay, so that's just showing you. Next. Okay. So instead, we want to practice targeted selective deworming, where you're only deworming the animals that need it the most. And this has been shown to prolong the efficiency of a dewormer. And it's also very important for farms that, like organic farms that really can't use dewormers except for emergencies. Keep in mind that your parasites are not equally distributed in all your individuals. And so when it comes, you've got your bell-shaped curve of who's highly resistant. So when it comes to barber pole worm, only about 20 to 30% of your sheep and goats in your flock harbor 80% of the worms, and they're going to be responsible for most of the egg output and the pasture contamination. And if you deworm early enough, you're only going to have to deworm those animals and not the entire herd or flock. If you're not deworming or taking care of the problem, then more and more of the worms are going of your animals are going to have heavy worm loads. So it's not going to matter that 20 to 30% of them have 30,000 worm eggs per gram versus the other, rest of the animals only having 10,000 worm eggs per gram, so next slide. So you do need to deal with that problem, whether it's by deworming or getting them onto uncontaminated land or what. And so in this slide, each one of these bars is an individual animal. And so you've got some individual animals that have more than 16,000 worm eggs per gram. And then you've got other animals that barely have any worm eggs per gram. And yet it's only really these top animals, these animals with super high loads that need to be dewormed and that are the ones responsible for most of the contamination of your pasture. So next slide, next thing, if you hit, okay. So if you deworm those 33, if you deworm 1/3 of your goats, the 1/3 that has the most worms, you're going to get rid of 80% of the eggs. Next slide. Okay, and then what'll happen is you've gotten rid of this group. Okay, these are now, if you've been able to use an effective dewormer. Next slide. If you keep going. You've reduced, if you've been able to use an effective dewormer, if something still works in your herd, you've reduced these to here. So these are carrying the resistant genes very likely, but if you crossbreed them with the rest of your population that didn't get dewormed, those resistant genes are going to get diluted in the whole genetic pool so that you're less likely to quickly build up dewormer resistance. You're still going to be building it up, but much slower. Okay. All right. Okay, next slide. Okay, but how do you determine who to deworm? You can try and do fecal egg counts, but they're costly. If you're doing them yourself, they're time consuming, and they don't necessarily identify animals that have a low tolerance to worms, but aren't shedding a lot of worm eggs. You can look at visual cues and production records. Next slide. So when it comes to barber pole worm, we suggest using barber pole worm as part of a 5-point check. Okay, and 5-point checks are ways to monitor your animals to try and decide who needs selective deworming. And you can also use, fecal egg counts to be helpful in that, but you don't have to be fecal egg counting the whole herd. And if you don't have access to fecal egg counts, 5-point checks can be very, very, and a very effective tool. And so you want to include FAMACHA in this. And we said that one of the main signs of barber pole worm infection is anemia. So you check to see if what the animal's membranes look like, their mucous membranes in the lower part of their eye look like. And using a system like this has been shown in studies to significantly decrease how fast your dewormer resistance develops. Next slide. And a 5-point check can vary depending on what country you live in, what worms are your big problem. But what's often used is in the US is checking the FAMACHA score on your animals, checking to see if the animals have a bottle jaw, which would indicate a really heavy dewormer, heavy barber pole worm load, though it could also be that they've got liver fluke, unfortunately. So you would check those things. You would check to their body condition. If you're keeping weight gain records, are they gaining as well as the rest of the herd, or are they gaining poorly? Is their hair coat rough, or is it nice and shiny? You look at their DAG or their fecal score. Do they have diarrhea, or is their feces nice and firm? Of course, keeping in mind the time of year that this year they're going to be fairly loose. And then what kind of movement do they have? If they're anemic, they may be they often will be lagging behind the herd as you move from grazing paddock to grazing paddock. And so you can adjust this system, to your own, to what works for your farm. When I've worked overseas, sometimes we're having trouble with nasal worms, and so we'd be checking the nasal, the noses as well. You can see what works for you. But this is what we generally use and what we'll be teaching at the workshop next week. Next slide. And we're trying to look not only at barber pole worm, but your other strongyle worms as well. But you have to keep in mind that other things like coccidia and liver fluke can be causing issues. And we'll be showing this next week, how to do this. You don't want to just pull down on the lower eyelid. Instead, you're usually pushing in the eye into the cavity, the socket there, and then that causes the lower eyelid to sort of bulge, and then it becomes easy to pull that out or push down on it and see it, and it bulges out, so it's easy to see the color. And then you'll use a FAMACHA card to compare the color and to see how anemic the animal looks. And you normally treat adults if they're at score 4 and 5. We'll often treat lambs as kids if they're even a score of 3. And then there's and then, as we said, you don't want to do this in isolation. And I would say bottle jaw, because it's a breakdown of the proteins, you usually see it later on. So the animals are usually, if it's being caused by barber pole worm, the animals usually have quite a high load by the time you see bottle jaws and are usually pretty anemic. Okay, next slide. This is what the card used to look like. It was a really big thing and harder to put on your wrist or harder to hold. You can see this animal looks a lot more pale than the animal on the previous page. Some disadvantages of FAMACHA is you need to do it in sunlight or very bright lighting. Obviously, I don't know about in Vermont, but in New York, if we waited for sunlight, there'd be a lot of days when we couldn't do this. If you are having to do it inside, the way this farmer Jim Taylor is having to do here, then using like a 500-watt quartz work light or shop light can be really helpful. Otherwise, if you can do it near a window or a skylight, that can help a lot. And during the grazing season, we say you need to do it at least every 2 weeks. Remember that it's only good for barber pole worms, so that's why you would include the rest of those things on your 5-point check. And we'll talk more on next Monday about what other things, obviously, if it's really dusty out, your animals could have red membranes from dust irritation, or if they're running a high fever, they could have red membranes from that. Next slide. And there's other causes of anemia in sheep and goats. Now, one thing to keep in mind, if there are less than 10% of your flock is in categories 4 and 5, then you would treat those animals and you would re-examine the herd again in 2 weeks. Okay, and you would want to be treating them with an effective dewormer. And if you don't, obviously, if you're organic, some of the other things you can do is put them in the barn on really clean, where they can't reinfect themselves. But even then, I mean, once there are 4 or 5, you really do need to usually get an effective dewormer into them. And unfortunately, Fiesta Farms dewormer usually isn't going to work at that stage. Next slide. However, what you need to keep in mind is that if you've waited long enough that greater than 10% of your flock and herd is in categories 4 and 5, then the recommendation for FAMACHA is that you would usually treat all the 3s as well. And often when you reach that case, most of your animals are at least a 3. And so that means you're going to end up treating a whole bunch of your animals all at one time. And so you really want to not get to that stage at all possible. Once that happens, you also want to start treating the herd at least, or checking the herd at least once a week, which is easy to do if you've got interns that you've trained to do it and you need something for the interns to do once a week. But otherwise, doing it yourself is time consuming. And you don't want to treat all the animals before a move. You would treat, half of them before you made the move, and then the rest of them, a couple of days after, or during, a couple of days after that move. So you really want to avoid getting to this stage. And unfortunately, for most people, what we do is we look at a couple of animals and we say, oh, they look good. I don't need to look at everyone. Looking at everyone every 2 weeks is way too time consuming. And so you let it go 3 weeks or 4 weeks or 5 weeks until you suddenly realize that, oh my gosh, someone is really anemic or someone has a bottle jaw. And then you check everyone. And by that time, everyone, most of them are 4, 5s and 3s, and you've defeated the purpose of FAMACHA. So I'm really serious when I say that, unfortunately, you do really need to be checking at least every 2 weeks during the grazing season. Okay. Next slide. Okay. All right. And then it's recommended to treat the 3s when greater than 10% of the flock or herd is in 4s or 5, or if they're young animals, or if they're vulnerable ewes and does, which should be around the time of lambing and kidding, during peak lactation, thin, poorly conditioned animals. And if you're down to one effective dewormer, we'll often recommend that you use your less effective dewormers on your category 3 animals and your effective dewormers on your category, on your 4s and 5s. And nowadays, next slide. Next slide. Is this the next slide? And nowadays, we'll often go ahead and say to give a dewormer combination to those animals that are in your 4s and 5s. So you wouldn't mix the dewormers together, but you would give them dewormers from 2 different families at the time you dewormed. And then you would only give one less effective one possibly to your 3s. But you want to, when you do that, you wouldn't want to be deworming everyone with a combination dewormers. Don't buy resistant worms. When you bring in new additions to your herd, it's really important to quarantine them if possible, get their manure in your compost pile rather than out on your pastures. And often, depending on whether you're organic or not, if you're, obviously if you're organic, you wouldn't be aggressively deworming them, but you would be doing an aggressive clean out of them, by quarantining them and stuff before you mix them into the rest of your herd. Otherwise, we recommend deworming them with dewormers from all 3 of the classes, but remember that any eggs they do lay after that for the next few weeks are going to be super worms. And so you're not going to put that manure out on your pasture, and then perform fecal egg counts to see if you have killed off their worms. Next slide. So this is part 3. It's what's in our future. I'll look at the chat for really quickly. Where do you buy
Yeah,
vitamins?
we were going to take a break here.
Okay. So shall we
You
go
can
ahead
do-
and take a short break here?
Answer the questions and then
Okay,
we'll
yes.
take a little break.
So vitamin E, you can buy it through online, I think through different catalogs online, and you would mix it into the feed or into the trace mineral. And some trace minerals do contain good amounts of vitamin E, so you can compare the amounts. It can be fairly expensive. I know I can look up who I was ordering it from, who I was originally ordering it from. I can look that up. And bottle jaw would usually be pretty late in the later stage of infestation. They're usually have quite a high barber pole worm load by then. Okay, so yeah, let's take a break. There'll only be about 7 or 8 slides here, so hopefully we'll be able to go through this part pretty quickly. But I know it's a part that's of major interest to people. So yeah, let's take a break and then we'll resume. All right, thank you.
Are you thinking just a couple minutes to grab some water? We are coming up close to the 8:30.
Yeah, so I
Okay,
was
okay.
thinking, like at the most, you just 1 or 2 minutes to go take a pee or drink some water.
Okay, great.
We talked about going over the pre-quiz, but maybe that's too much for tonight.
And Betsy, I also remembered that some of the pre-quiz questions are asking
Are in the
about
later.
copper oxide wire particles and stuff.
Ah, true.
Yeah. But hopefully we'll be able to do that, or at least with the people who want to stay on. I know I always take too long on the pasture stuff.
Well, that's a really important part.
Well, for people who are pasturing, it's really important.
That's true.
As you mentioned, sometimes we're not working with people who are doing a lot of pasturing, even though you and I both do.
Did you notice on that one matcha picture, they are holding the card in the wrong direction? Never
Yeah.
noticed that before.
Why don't you go back and let me see that for a second?
See?
Oh yeah, and that's not one of ours. That's one of
That's weird.
I wonder if those guys do that regularly. Yeah, that's University of Rhode Island. That's Catherine and those guys.
Oh, we're gonna have to pick on them.
Yeah, because come back to ours. Go forward.
I just had to
Okay,
find a little
sure.
thing. Yes,
Well,
see, that's how we would hold it.
Yeah, this is one of ours. I don't remember whose farm that's at, but that's one of ours. Okay, next one. So it looks like we have all 34 people back now. So should we go ahead and we'll get started. Okay, so we're going to look at some worm control strategies that are in development or are now being used. Next slide. So one of these was Dunningtonium flagras. There's in nature, there's lots of nematode trapping fungi. And a lot of these are, have evolved to live in livestock feces and to eat the gastrointestinal worm larvae as they hatch out of that feces. And the one in preliminary studies that were done quite a few years ago, Dunningtonium flagrus really stood out as a good one. And so they did studies in Scotland, and then Scotland sort of dropped it, and Australia took it up with, and International Animal Health developed these two products. One can be top dressed or incorporated into a feed or a mineral supplement, and the other one is a feed supplement that has the biowormer added to it. The animal unfortunately, your sheep or goat has to eat these daily, but the spore does survive travel through the digestive tract, and then it's excreted in the animal's manure, along with any worm eggs the animal has. And once it's excreted, it germinates and traps and consumes those newly hatched L1 larvae. Like I said, unfortunately, it seems to have to be eaten daily, though there were some studies several years ago where they did try feeding it every 2 to 3 days, and it seemed to be effective that way as well. So last year, the biggest problems we had with it was that it was quite costly, and some people, especially when they initially would feed it, said that they were having palatability issues with it. But that seemed to, in most cases, for most sheep and goat flocks, they got used to it pretty quickly. But it was about the same cost. It's pretty close to the cost of feeding your animals hay, and the big problem we have with it right now is there's a shortage of there's been problems with the spore production in Australia. And so even though it's been accepted for organic use in Australia and New Zealand, they're not exporting any of it to the US right now. Premier was one of the carriers of it. And then of the biowormer, there were, feed mills could order it directly from IAH. But right now they're saying that except for research purposes, it's not available, and they're not sure it'll be available by late summer even. Okay, next slide. When it comes to vaccines, there was a breakthrough in Australia where they developed a system to centrifuge the worms, where they were able to harvest much more of the immunity inducing antigen than they had previously been able to do. They're able now to get a lot more. They've been able to adjust things so that they're able to get a lot more. But we still have not been able to synthesize the antigen for barber pole worm. And that vaccine is very dependent on having slaughterhouses that process lots of lambs and goats, as they do in Australia. The vaccine is called BarberVac, and they have not registered it for goats because the effectiveness was too variable in the studies they did in Australia. Some of the studies they've done in Latin America, it was more effective, but it wasn't efficient enough to extend the registration in Australia. And it requires quite a few dosages. The animal's not protected until the 5th dose. So it was thought that you would only use it on lambs, that you wouldn't use it on adult animals. It would primarily be for lambs, and it is fairly expensive. And so the thought is that it's pretty unlikely to be marketed in the US. A few years ago, Canada was interested, and they were trying to do an effort to get it approved for both countries, but it's very unlikely that it's going to get approved for the United States. Next slide. And so far, I haven't heard of any breakthroughs on synthesizing the antigen. We have copper oxide wire particles. It only works on worms that are in the true stomach, in the abomasum. So it doesn't work on a lot of your gastrointestinal worms that are mostly in the intestines. So it does damage your barber pole worm. It doesn't damage brown stomach worm. And that's because if you have too many brown stomach worms in your animal, brown stomach worm attacks the gastric glands, right? And so by attacking the gastric glands of the true stomach, it means that you don't get as much gastric juice being produced. And so the true stomach, one symptom of brown stomach worm is the true stomach of a heavy infection with brown stomach worm is that your stomach doesn't get acidic enough for good nutrition. That's why the animals look like the one animal, look like their digestive tract is upset. They've got rough stomachs or rough coats and all that, is because it's not getting acidic enough. And unfortunately, the true stomach needs to be acidic in order for those copper oxide wire particles to be dissolved. So you don't get good dissolving of the copper oxide wire particles when your animals are heavily infected with brown stomach worm. And so we already knew that there were these problems with it, with the copper, and the copper should be causing lesions on the barber pole worm. And it seems like some worms are evolving to not get those lesions, maybe to have thicker skin. And then it also should be boosting the immune system. The copper travels to the small intestines after it's dissolved and is absorbed there. So you have two mechanisms by which it should be fighting the barber pole worm. Next slide. So we did studies with, I don't know, 20 farms or so, a lot of farms in New York with copper oxide wire particles. And in most of the herds, it did not work as effectively or as abruptly as a chemical dewormer. We did found that when it works, a 0.5 gram dosage per lamb was as effective as a 1 gram dosage per head per lamb. It was a little more uncertain with goat kids. It seemed like you needed a somewhat higher dosage maybe, but we also found that on the goat kids, it was a lot more variable. On some farms, it didn't seem to work at all. And keep in mind that the Cornell Vet Diagnostic Lab has observed some some poisoning and resulting in death in lambs that got 2 gram dosages at other places. And those have been on flocks where the flock got 2 gram dosages, and most of the lambs did great. And then some lambs that underwent stress because they got sold to other farms got copper toxicity. Okay, so that's the thing with copper toxicity, it becomes much worse under stress. We did find that there was one farm, and this was the extension learning farm that Betsy is associated with. It had a effective long-term impact all 3 years of testing. But on most farms, we only found a short-term effect. So we didn't know if possibly the extension learning farm is a little deficient in copper. They don't use any copper in their mineral mix, and they feed almost no grain at all. And usually the grain has no added copper to it. So we didn't know if maybe the immune systems just really, really responded to the copper being there. But it's very variable from farm to farm is what we found in our studies. And so we don't know if it's the diet, the timing of the dosing in relationship to the timing of infection. It seemed like if animals didn't have any barber pole worm until a month or 2 later, it wasn't very effective. At the same time, if the animals had super high infections of barber pole worm, it didn't seem to be very helpful. Probably has a lot to do with the acidity of the true stomach. And it seemed in our studies that it worked best when animals already had some worm load when they were dosed, some barber pole worm load when dosed. When we gave it pre-weaning, though at the extension learning farm and other farms, it did work great 2 weeks post-weaning. And also when the animals were not consuming large quantities of grain. It seemed to work better at the grass-fed farms. But we need more controlled studies comparing different types of flock management. So don't feel like, oh, I'm going to give copper oxide wire particles and they're going to work on my herd to control barber pole worm. You really need to look and see if it is effective on your herd. Follow it up with fecal egg counts. Next slide. And one thing that we recommended and that is recommended by the American Consortium, by the researchers with it there, is to use it on your threes. You know, use copper oxide wire particles, and it's very low dosages of it. It's only a 2-gram dose in adult animals. And like I said, a 0.5 gram dose seems to be very effective in lambs when it is effective. To use that on your animals that on a FAMACHA score card are scoring 3s, and then use an effective dewormer on your 4s and 5s was sort of the recommendation that a lot of us are making. And then I mentioned earlier condensed tannins in forages. And so there have been studies in the Southeast US where they've seen that grazing the forage legume Sericea lespedeza for 4 weeks or more, as 25% of the diet or more, reduced the strongyl worm populations in sheep or goats. And they thought it was because of the particular condensed tannins in the plant. And it seemed to both cause that sheath to not come off the L4 larva when the L3 got into the animal. The L4, the sheath did not come up off the animal, so the animal couldn't suck blood, and so the animal, the worm died. And also it seemed to reduce hatching. But Sericea lespedeza is not winter hardy in the Northeast US, and it doesn't go to blossom and it doesn't set seed very easily in the Northeast US. So instead, in our studies, we looked at bird's foot trefoil, which also is fairly high in tannins. We didn't look at sandfoin because sandfoin doesn't grow well on acid or wet soils. So it wasn't ideal for New York, where we have a lot of high acid and wet soils. Not all condensed tannins seem to work. They've done studies with oak and peanut skins. There have been variable studies with grape pulp. They did some studies at University of Rhode Island with cranberry leaves, where initially it seemed promising, but it didn't work out that well. Sericea lespedeza is a real heavy water user, and so it is considered a noxious weed in several states. And it was used in the past. NRCS used it as a erosion control plant, but because of that heavy craving of water, as I said, it is considered a noxious weed in some states. At Tuskegee, they've looked at using ground pine bark as a major part of the diet, but again, the animals don't grow great on it, so there's trade-offs there. So in our studies, keep going. Next slide. So in our studies with bird's foot trefoil, so far, and I actually haven't analyzed the data from last year's studies, it does appear that when animals have a worm load, particularly a barber pole worm load, but even worm loads from other strongyl worms, the animals that are grazing bird's foot trefoil, the weaned lambs and kids that are grazing it, appear to be more resilient, as exhibited by better FAMACHA scores than animals who are on control pastures, on traditional pastures of your traditional mostly grass and some clover pastures. But we don't know if that was simply due to better nutrition. In a lot of our studies, the bird's foot trefoil pastures are so high in protein and everything that the nutrition, and TDN, that the nutrition was better. And we don't know if there are compounds in bird's foot trefoil that boost the immune system. It's thought that there is, and so it may be an indirect effect. Even though in the lab in Petri dishes, there are different varieties of bird's foot trefoil that do affect egg laying and do affect excheatment. We did find that grass-fed lambs and kids appeared to grow very well on lush bird's foot trefoil pastures. We had grass-fed lambs and kids that were growing 1/3 to 1/2 pound a day on these pastures, which was better than they were generally doing on conventional pastures. but we still don't know whether grazing bird's foot trefoil for at least 4 weeks is helpful to control the strongyle worms. Our deer lambs and kids, you would put them on these bird's foot trefoil pastures. And it's already also really hard to maintain a pure stand of heavy stand of bird's foot trefoil. It's outcompeted pretty easily by clover and alfalfa. Fox, where copper oxide wire particles are effective and barber pole worms are present, dosing with copper oxide wire particles and feeding bird's foot trefoil, same for kids as well. We ended up getting lower FAMACHA scores and lower and improved weight gains as compared to only doing one or the other. So in combination, they seem to boost each other. Next slide. But as far as being an acute dewormer, the bird's foot trefoil so far hasn't shown that effect. There's also now a crystal protein of bacteria, Bacillus thuringiensis, and you may be aware of Bacillus thuringiensis from BT from using it for organic vegetable control, for corn earworm and stuff. And they found that in nematodes in your crops, that cry proteins from BT eventually result in death of the nematodes. It intoxicates them and they can't function well. And then, but in there, it's not is that it may not be stable in the ruminant digestive tract. So in a modified form where the cry 5B crystals are encapsulated within dead BT cell walls, they achieve and reduce their fecal egg counts by 90%. It seemed to be more effective against female barber pole worms than male barber pole worms, and it killed like 96% of the female worms. It's been doing well in the testing they've done this year on it as well. One thing I forgot to mention, University of Rhode Island was trying to do a study with Dunningtonium flagris on last year with sheep, and they had trouble with it because they were mixing it into a trace mineral that contained a coccidiostat, and they were getting no reaction with it, and it was not surviving, and it seemed like the coccidiostat was actually killing the fungus. So that's something to keep in mind if you are using, if you ever have an opportunity to use the Dunningtonium. Okay. I also did talk today with a company, with the CEO of a company called Microbes Biological that has a series of compounds that they've I don't know if they've trademarked them yet. I know they've registered the name. I think they have the name with FDA. It's called intranem, NEM, like nematode. And it's been pretty effective at killing crop nematodes, and they've used it on barber pole worm, and it seems to be effective. They haven't gotten as far on studies as far as trying to do trials to see what kind of dosage would be most effective against barber pole worm, but they believe it would be able to be organically certified. They are looking at it for meningeal worm, but the scientists working with them are thinking that it's not going to be able to pass through the blood, be able to kill. It would be like ivermectin, where if it does kill deer worm, it would only be killing it in early stages. But they do want to look at that more. But they're still many years down the pipeline as far as development. But they would be hoping to market it as an organic, for organic farms. So that's where I am, and I believe let's go. But I think that's the last slide I have. Yep. So finally, questions, and thank you all for being so patient.
Great. I'm just gonna step in and say our captioner, Jordan, who's doing the live captioning, has to go because we're over time, but whoever else wants to stay for question and answer section, that's great.
And we can also go through the quiz if people have questions about what are the right answers on the quiz. Okay. So since it's sounding like there are no questions, Betsy, do you want to go over that quiz that quiz at all for people?
I can if people are interested. It is late.
Yeah, is anyone interested, or do people want to just get off? And there would be no bad feelings if you want to get off. And we could probably even send you the right answers to the quiz so you can compare them.
We can definitely send out that. I don't know if that interferes with the post quiz.
Okay.
Or we can
Um,
wait and send it after our thing Monday if we need to.
Yeah, so we can send it after the post quiz. We can send it out to people, or after we give people a few days to respond to the post quiz. There is one question in chat, or is that just the thing about, yeah, people needing to hop off? So I think probably everyone needs to hop off. So if no one, you're welcome to unmute if you have a question, and we'll stay on one more minute. But if no one has a question in the next minute, I'm sure it'll be fantastic for you guys to go be with your families or your flocks or your herds.
So I have one question. Does
Okay,
anybody
Cheryl.
know if horsetails are high in tannins?
I don't know if horsetails are. They're high in lignin, but I'm not sure. I think I'm not sure. I'll have to look that up. They've got some other compounds in them, which aren't the best compounds in the world. But I don't know if they're high in tannins. They're some examples of things that are high in tannins would be your sumac is really high in tannins. You know, anything that causes you to pucker. Your wild grapes, but you wouldn't want to get them mixed up with moonseed because moonseed is poisonous. A lot of your brush plants are pretty high in tannins, and so you know they're just it's hard to know. And if you do learn how to do fecal egg counting, then you know one thing you can do is compare before and after with different herbs you try and feed out and different plants you feed to see if they appear to be at your farm having an effect on your animals.
My sheep were self-selecting to eat them. I was told they wouldn't, and they did.
Okay,
So,
so that's
yeah,
interesting.
So I was just curious whether the thought process would be the animals maybe know what they need, and so they were eating them because they needed something in them.
And what time of year were they eating them?
It was springtime.
And was it fairly early in the spring?
It was early in the spring, and it was when I first got them, and they pretty much eliminated them from the area that they ate them in.
Yeah, because
they-
one thing would be because they are fairly high in lignin, even though early in the spring they're not nearly as high, but because they are, and a lot of our pastures in the earlier spring are sort of lacking in fermentable fiber. It may have been that they were going for them because they had at that point they had a lot of cellulose rather than lignin at the time when a lot of your grasses are high in soluble carbohydrates rather than being quite as high as they, you know, is optimal for the animals in their cellulose. So that may have been one reason they were eating them. I have to say, as I think about it, my animals, especially earlier in the year, do like them too.
Okay. And then what about diatomaceous earth or garlic?
Okay, so with garlic, there have been some studies where, you know, where it has seemed somewhat beneficial, and it certainly has other health pluses to it. You know, as far as garlic juice, it is pretty expensive, but as far as diatomaceous earth, there's been whenever they've done a scientific study with it, as far as it being an acute dewormer, it hasn't seemed to be helpful. And when they've looked at it, I mean, the only thing I've seen is a couple of studies out of the Southeast where where it seemed to dry out the fecal pellet a little bit and reduce the survival of the L1 and L2 a little bit, but it was very minimal. I think it was, and that was when it was being fed on a daily basis in pretty high dosages. So it doesn't seem to be that helpful for internal parasites. For external parasites on the outside may have more effect, but you know, there are people who swear by it, but you would want it to be the feed quality and not your fine powder that's used for pools and stuff.
Thank you.
So shall we go ahead and quit with that? And thank you all.
Thank you, Tatiana. Thank you, Betsy.